Okay, sorry for those watching the video later. I just realized I ran out of room on my disk, so I lost about 10 minutes of the video. You might have missed a discussion of these wrapper classes that we did. That's easy for people to pick up. Just by reading, you should be able to figure that out. The weird stuff are these application of stacks, and this is the main thing that we're doing today. And as I've been explaining, we're going to play around with a different way of representing arithmetic expressions so that we can process them easily with a stack. And the method is called RPN notation, and that's where you move the operators so they appear after the operands that you're going to process them. So the expression A star B plus C becomes AB star C plus. And so just to quiz you all, I'm going to throw some expressions up here, and you can try to figure out what the numeric value should be, right? So what if I say 3, 4 star 5, 7 plus star? What would the result be? $12 times 12 is 144, right? Yeah, because this gets processed down to 12. This gets processed to 12. And then we're going to times those two together, so we end up with 144, right? Good. So that's basically how that works. Let's see, what else could I do? You can do some fun stuff like, okay, what about 2, 4, 6, 8 star minus should I do, well, let me do slash. I don't know, that's probably dumb, but what happens if I do that? No, we're going to do floating point division. I think it's 1/22. And it depends on how the order works, right? But if you noticed in the examples that they gave us, like 5, 6 minus became 5 minus 6, right? You have to insert the operator in between the operands. So let's work this out. So 2, 4, 6, 8 star means the first thing we're going to do is 6, 8 star, which is 48. And then we got to do, oh, actually it's negative 1/22, I think, right? Then we got to do minus, right? Well, 448 minus becomes 4 minus 48, right? So that becomes negative 44, right? Sorry? No, then you're doing 2 minus 44 slash. That means, remember, the slash goes in between those two guys. So it means 2 divided by minus 44. So it's minus 1/22. Okay, you feel good? You kind of know what's going on? Okay, so how does that apply to stacks? Well, what you do, if you want to evaluate an RPN expression, you start with an empty stack, and after reading in the string, so you're going to read in the tokens, or maybe you'll read them one at a time, I forget how we're going to do it exactly, but you get the next token, which could either be a number or an operator. You can actually set it up in general so that it processes variables too, in which case you can start adding symbols to the string. But we're not going to do that today. It's either going to be a digit, and our expressions are only going to process digits. We have to enter them as digits to make it simple just to read the values. And so it's either a digit or an operator. And by an operator, that means plus, minus, star, or slash. And if it's an operand, that means it's a digit. We're going to push it onto the stack. And if it's an operator, we're going to pop 2 values from the stack, apply the operator on those 2 values, and push the resulting value back onto the stack. And when you reach the end of the expression, if it's a properly formed arithmetic expression, then the value of the expression is going to be the only thing left on the stack. That will be all that's there. You can spit that out, and that will be the result of the expression. So it's a fun thing to apply our understanding of how stacks work to try to solve this. And again, here's another example if you need that to kind of see how that's going to work. It actually shows you how the stack grows and shrinks as you process the expression. So here we are with the 2. Here's our first item, and then we're going to do the 4. Okay, that goes on top. Star. Okay, we chop it down. We keep adding. So the stack will kind of grow and shrink as we process that expression. And here's some more things you could try if you're not sure how that works. And if you want to actually convert from infix, you could do another thing. Anyway, there's more stuff you can do here. This is more than what we're going to be doing, but I think that is it for the lecture. So let's go back to the lab, have you tackle this crazy problem. Put a slash in there to activate. And here it is. The way it's going to work, we're going to enter a postfix expression as a single string in one line. And we are going to define a symbol variable, an operator, operands 1 and operands 2, and a value. And we're creating a num stack as a stack interface of double, which is going to be made out of a linked stack. So it's a stack of double. Even though we're just entering digits, because we have division, we might end up having fractional values. So we're going to use double to represent all the values. And then here is the beginning of the loop that processes it. We're going to use a for loop to read one expression, one character at a time from the expression, using a char at method for a string. And this is showing us the printout of that, so we can run this. This will actually compile, but it's not really going to do the processing yet, but it will actually read the value for us, which is helpful to have in place. And you enter a postfix expression. Now you can type something like, like I said, 3, 4, star, 5, minus. And that should have given us 12 minus 5. That should have given us 7. But it's actually just printing out the symbols for us, just to show you that we can read the symbols properly. Now your job is to write the code that implements the processing step that we just showed you on that slide. I'll bring that up again. So you're reading each symbol one at a time. If the symbol is a digit, you're going to push it onto the stack. Otherwise, if it's an operator, you got to pop off 2 values from the stack and do that operation on them, and then return it back to the stack. So why don't you guys start tackling that, and I will come around and help you if you run into any problems. Question? Better yet, I'm going to show it because the algorithm is right here, and you can pull that up too if that's the wrong class. That is circuits. It's not this one. There's a few algorithms here for different things in the stack. It's this one. Let me get rid of the.
How do we parse a character to be an integer?
How do you parse a character to be an integer or a double? We did that, I think, already, right? Didn't we?
Is a character an integer not correspondent?
There is the get numeric value.
Oh, character. Okay.
Yeah.
I was calling it
So you can use that method to convert a digit into a double, a character digit into a double value. Okay, that symbol is going to be read in as a character, right? So everything you need to know is already in the lab file. We've used it or we've demonstrated it in one way or the other. And you can use this, right? This converts char to double. So you don't have to print out the symbols anymore unless you want to, but you can. What's fun is to print out the contents of the stack after each symbol is processed. You can kind of see the stack growing and shrinking after you have it working. Okay, I'm going to pause while you're working and come around and help if anyone has any problems. Yes, and this is the algorithm that you're going to be following. Jacob asks, should we have if statements checking what the operator is? Yes. But the operator is a char, the symbol, right? And if it's a plus sign, you have to add the two operands together. If it's a star, you're going to multiply them together. Yeah.
Should we keep it simple and only use like the 4 basic ones?
Yes.
Plus, minus, divide, multiply.
Yes, just use the 4 basic ones, plus, minus, star, and slash. And then for extra credit, you can see what the extra credit options are down here where it says what to turn in. And you're not going to turn it in until you finish part A of Lab 3, but the extra credit, one extra credit is add the exponentiation operator, so you can do exponents. And you can do an S symbol, you can squeeze the letter S in that string, and that'll give you the opportunity, you can make that, you can code up an S so that if you have an S, it gives you the square root of a value. The square root only takes one operand, but you can do that. And you can demonstrate that for 1 extra credit point. And this also, the other extra credit is also for Lab 2B. There's no extra credit for the array one. But in this one, you can make a stack sort method, which is at the end of the Lab 2 handout. If you're really intrigued by stacks, you can make a method that sorts them, following the guidelines. One of the guidelines in this section here. It says 3 points, but you're only going to get 1 point, I think, for that.
Where do we find these resources?
This is in your lab handout, so you should have a hard copy of it. It's also on the everything in the lab is right here. So it says when it says follow the instructions at this link here, follow the part B instructions at this link. You click on that, you bring up the lab handout, and you read on, and it's at the very bottom is the stack sort algorithm. Yeah, no one reads my lab handouts, but they were really helpful for me because otherwise this would be complete chaos.
I think that's how it is.
Just when you're doing the
Because now it's popping off every single one. Yeah, but don't you want to pop?
when you're doing this, a good test string is a test expression would be 3, 4, star, 5, 3 minus slash. that should give you 6. Some people mess up the order of the operands because this is supposed to be, this is supposed to be 2, this is supposed to be 12, and this is supposed to be 12 divided by 2. But some people, if you do the order wrong, you'll do like 2 divided by 12.
It's because it's null. It's pocket. That's what.
Well, I think there should be enough okay, soft ass. Power.
Yeah, math.power.
Okay, I'm gonna try.
Yeah, math.square root. Yeah.
I only have those 3 So inside then each, okay, so you're gonna check if it's plus, what are you gonna do? You're gonna add them and push them back inside. So we have to go, so num.
So you need num stack dot
Push.
and then put that inside.
Yeah. OP1 plus OP2.
Run this assembly now.
That push.
Oh yeah, whatever. So
Back, you need to push it back. You need to push it back on stack.
it says it in the log. Short forward, then I'm gonna make.
What does it say?
We'll push onto num stack for some. You have to push the value back on to stack.
I don't know where the notes are separate.
Outline, right? What was that?
Now stack yeah.
Takes this
Oh, I wrote OP2. The plugin? Yeah, try and change it. Put 2 here, the one.
Makes an array of X values. That pulls the X value.
Oh, wait, it's for when it gets valid, right?
Yeah.
Okay, so
Not
I just put in like a random number. Because the way your code is structured, it doesn't know for
This
sure
is just, when I click on this,
if UI actually.
say I click on right, when I click on this, it cuts lines on the side of the equation,
And that's
and then the left side is one.
or like, I mean, it doesn't matter. But that number.
His works.
Yeah, mine works. I don't know.
With
Mine-
hard so you set the okay.
Question.
Hang on.
But that's the way my code is structured.
Are you lowering how I think I'm like that. That shows up in class about yeah.
Okay. Yeah. I wonder if there's some bracket somewhere.
Yours is yours is all of it is inside the cluster.
Yeah.
Mine
So mine figured out mine, I fixed mine. It doesn't give me
How did you fix the number?
No, I just put everything, I specified the actual, as in I did everything as an else, yeah?
So it's all
Oh, okay.
Else?
Because, Elsa, I have Elsa. Because before mine was Elsa. I don't know. What is it?
And then when I click on this one,
So for plus and times, it doesn't matter which one you do first. But when you're doing minus and divide, make sure you do OP1 divided by OP2.
What does it say? OP1
Otherwise, yeah.
Stop drawing. Does this matter? Does it matter if it's like why does it matter?
Yeah, because
the first one didn't possibly move down, so it's like this too. It's gonna affect
well, I think it doesn't matter as long as you stay consistent.
Yeah.
So the first time, so let's say the first if you're plugging number OP2 first.
Right.
Then if you are subtracting, you have to do OP1 minus OP2. But if the first one you're popping is OP1, then you have to do OP2 minus. Yeah. As long as you stay consistent.
Just stumps it
Yeah,
out.
they have to actually be.
Because I didn't have a result.
Yeah.
Oh, it's because this is outside of here. So if, oh no, you have an else. I think you just have to have an else statement. So, I don't know. I just said it.
Yeah.
I've already typed it. 2, 3, 4, 5, 6. That's a plus sign. Oh shit, yeah, minus. You got the no pointer. Oh my goodness. It's alright, I've been sitting here with the same problem. But like, I don't know. Dude, I want to. Get
Yeah, OP1, because this is the way it works. The one that you popped first, okay, and this one says you popped second. So when you subtract, you're subtracting this from this, the one that popped first. Yeah, the way it works. So if you pop 2 first, then you have to go OP1
Basically random.
and then OP1 divided by
I'm still getting.
not the other way around.
Yeah, you could.
So now go ahead and run the. Try something, I don't know, it's like that one, maybe.
I'm pretty sure yours won't work.
And this is
That's simple though. It's not just
Yeah, go ahead, yeah.
Oh, you're supposed to try 2.
this is equivalent like somebody
I know what work.
That's just a really simple thing. You can see the it's interesting about one of the random walk with that law.
What year for?
Yeah.
Wait, what is the result? It's supposed to be.
Yeah, mine's.
But are you doing what's up there?
No, he's doing the
I was
slide
doing
that
the slide.
it doesn't matter if you're
Okay, so what was wrong with mine? Is that like I was treating it when I was entering it, as like 7. So you need to enter it all together.
Yeah.
What?
This means that's
I'm hella.
What were you guys doing?
We were spacing it.
Yeah. No.
Yeah, dude, that's what I was doing this whole time.
Oh yeah, don't do that. Don't do that.
Are you? I'm hella mad. Yeah. Wait, hold on. Dude, I'm over here freaking out.
Oh, you guys should ask me. I told you. Yes, this is amazing.
Dude, gotta trust Austin, man.
Isn't that a
No, you have it all under the character dot his digits. Right. Oh no, wait.
But that becomes more of a.
Oh, you're not pushing it, dude. You gotta push. Dude, come on. Dude, put that. Put value equals.
What you have to do?
No way.
I mean, I am pushing. Now I'm
No,
starting to push.
put that in all of these and see what works. But I mean, this would wait. No, that's a waste.
Do you have to set it equal to value?
No, you could probably just do numstack.push op1 minus op2. Or like most. But like that way I could just set value every time.
Right.
This works. Yeah.
This is, I should do the same thing. I'm fascinated by the way that this could be done. I had a
2, 3, 4 plus 5, 6 minus star. Nah, dude, I think he's gone. Well, sorry to fuck up. I don't know what you possibly. Yeah, I feel like it's like the same thing you have. What's the value of double test? Under your, what's the test? What's the cycle? Oh, it makes it into a double. I just have value equals character dot numeric value.
Having a random.
Except that value.
Allows.
That's it.
Not just that one thing, it forces them to be abstraction. And be more, robust scenario. So somebody can get lucky and just get hurt.
Right.
Now,
I'm doing that.
if you rely on course, you have to.
I have the same thing.
So that's kind of what I was thinking. So really,
I'm gonna make yours.
Yeah.
I like working with
I've been on getting a lot of fun with it. I haven't worked with it. I'm gonna play it and then I'll probably come back and tell you. I don't expect you to all right. No, yeah. Okay. Okay. Now, if it doesn't work, I'm just gonna say. I don't know if I got left on the line. It's like before it was.
You gotta find some way to use these things. That's what this platform.
No. Okay.
And all the examples.
What could possibly?
You'll probably.
Wait. Like, there's a list.
Make a list of things. What's the something? Oh, the little class. Yeah. With the same thing. Oh, single object. So it's a whole level.
Right. Well, I'm already trying.
And you can find ways of. Actually, just a plain game.
I mean, yeah, that's the goal. Because once I build a level, then I can start messing with it. This I actually made up. If this fixes it, I'm going to use it more. That was a typo on mine. I did not do that on purpose. Oh, dude, that makes sense. Yes, that's gonna fix it. Create a function. That is plus the base of that. This is the okay, I did this as a typo, and it's the only reason my was running my OP wrong. I put OP2 first and then OP1 second, and I only did that by complete mistake, and that's the only reason it came out right.
Yeah, that's not supposed to be.
Yeah.
That makes sense.
It makes sense. Dude, Austin Reitz, and he's like already done it, and then we're just over here like, who the fuck are we supposed to know this? And he's like, dude, it's on the page. That's like the third time in 45 minutes. He's like, dude, it's on the page. Wow, man, we're joking.
Yeah.
I'm normalizing it just out. normal.
Using a lot of point C on
That's
this.
funny.
I didn't hit that.
Yeah, he wants you to print that one more time. Like pop the
They do a lot of
last.
stuff.
Pop the last.
So just
Yeah,
just
that's
the answer back.
So like my next step is gonna be once I have the whole level, I'm doing physically real one, we're basically removing it one at a time. And then set the center point up equal to this line, yes, where it's actually going to be. Because if you just set the center point like this,
Taking the screen off them?
something linear. Yeah.
Really?
Yeah.
Yeah.
That's pretty cool.
That's very cool.
This has to be
Oh, yeah. We smacked it. Oh, yeah.
What did I do?
But his grades like all it's like pretty much all the tests.
No homework.
Yeah.
Doesn't collect.
Well, does he do any quizzes?
No.
So
All of this like
No. No,
he's not that-
no. He gives you the list of homework at the beginning of the semester. He gives you a list of homework for every chapter. You are highly recommended. But other than that, he doesn't collect homework, doesn't do no study guides, nothing. I mean, if you ask him questions, he's very approachable. But and he'll tell you like before the test, he'll tell you kind of what to expect. Like I'm gonna give you this problem with this guy, maybe two problems with this guy.
Okay, so he'll tell you like something.
Yeah, but he's not gonna tell you like he's not gonna give you any handouts.
I can.
And extra credit, he's extra credit stuff.
working together.
And I think you can drop one test.
Oh, that's pretty good.
Yeah.
Is it replacing the final or just
I think you cannot drop the final.
No. They'll like a lot of teachers will do like first test and then replace the final.
There's a credit. No, you just drop it. You just drop it.
Lots of ways.
Yeah. And
Oh look, now these are showing up.
I don't think he correct.
Yeah, there can only be.
It's because they have a line on it.
No, it should be the same. Derivative of whatever. Gonzo Boyo.
Yeah?
Hey John, that's like the first thing it says to me. I'm in hella mad. I'm in hella mad. No, I went back and read it the first time. No, you know what really happened? I probably read it and then typed it and then I completely forgot about it. I never read them.
What's the OP?
Yeah. So I probably did it because I read it really like subconsciously. No, I probably because I read it. So I probably read it and then entered it and then I forgot about it immediately. Yeah.
Wasn't taking any pictures, no. No, not at all.
Okay, so it's like last thing.
Yeah, that's
Now I can
You can do an extra credit.
Oh, what's extra credit?
Extra credit with a similar thing.
I think it's it. Yeah, you can look at square root and
Create 200 stacks. Dude, I'm not gonna do any extra credit because it's so fucking pointless. It's like, it's like one. Yeah, it's okay.
Dude, you can have it. I think you ever.
Imagine if I was a boss.
So all we're doing here is
Dude, that's an advanced shit.
It's a equal. And basically,
I don't think it'd be that hard.
I feel like
If you just have to add square root and square, that's it. I've read it. That's like the easiest part.
it seems pretty similar to what we've done. Are you gonna do it right now?
Like, I'll do it later, maybe.
I don't know what character.
Yeah, there's a math about square root.
Yeah, but I don't think because
How are you going to take that? Oh.
Like S? Yeah, does that work? Wait, is the character work that way?
That's exponential. That's exponential.
Okay, yeah.
That's to represent.
How about math?
Yeah, so you can do that to in one time.
Right. Yeah.
You're.
I
You're
think that's a
saying.
method, guys.
Oh.
Math dot.
Hey, Scott, I was
Oh,
wondering if you're starting with my stack sort.
Yeah,
I just wanted to
It's
ask
like it's a half hour.
Yeah.
Yeah, but then that would take
like,
that's
so
that's
as
four
to
characters.
hold, the small,
But-
small
but you can-
Because it's
I don't know how you do it.
Yeah, you can just do that.
You can
It's empty stat.